12 Mindsetters, welcome to today's maths show. Today we have a special revision lesson on calculus. We have selected highlights from lessons shown earlier in the term to help you revise. Please post your comments and questions on our Facebook page on facebook.com/learnextra or on Twitter @learnextra so we can help you with your revision. You can also download the notes for today's show from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
Use the remainder theorem to determine the remainder when g at x, which is 4x cubed, there's the g at x, when it's divided by this. So we have to determine the remainder if this polynomial is divided by that linear polynomial. What it means, from this you can deduce that, okay, what you can do is that from there, x plus 4 equal to 0, therefore x is equal to -4. So -4 is the value you have to substitute in your the polynomial we have. So we have to find g at -4. So we have to find g of -4, then we'll get the remainder. I'm just making the big R for remainder. Okay, let me fix this. This is g of -4. G of -4. Let me do that. So I'll get a remainder. If I take my g at x, which is 4, where I see x, I put -4, which is -4 to the power 3. For this part also, I put x, I get -8, bracket, -4 to the power 2, plus the -4 plus the 2. What I did is just to get my remainder. Remainder, the big R denote remainder. Some textbooks use small r. For now, we use the capital letter R for the remainder. Then what do? You just put this in a calculator and you get a remainder. Let's see how you do this. Okay, you just say 4 bracket -4. You have to put this in bracket to the power 3. Then plus, what do we have? Not plus, -8. This is in bracket, -4, bracket, we have what? Squared. Then let's see the second part. So then for we have -4 there, plus 2 equal to, I get -3, I get remainders -386. This is the remainder. If this polynomial is divided by x plus 4, what do? I just solve that x, then I get x is -4, then I take that value, substitute that value into your polynomial, then we get a remainder, which is -386 is the remainder. Okay, good. I hope you understand this. Good. Let's look at the next question. Now, the next question, use the remainder theorem to determine the remainder when same polynomial is divided by x minus 2. The same principle. Then you say x minus 2 equal to 0. You get that x is equals to 2. Then if you take g of 2, you will get your remainder. In this case, I said the capital letter R denote the remainder for the polynomial when it's divided by this linear function. Then what do? What do? We just take 2. Where we see x, we substitute 2 there. So we get the remainder. If 4, bracket, where I see x, I substitute 2 to the power 3 minus 8, bracket 2 to the power 3 plus 2 and the 2, then what do? You can take this and put it in a calculator, which is, in this case, because I've been doing a calculation, I have to clear there. Then what do I do there? I get 4 bracket, which is 2 bracket to the power 3. What do I need now? Minus 8 bracket. What do we have? 2 to the power. Oh, I think I made a mistake. Good, I can see my mistake. This is not to the power 3. This is to the power 2. This is to the power 2, which is to the power 2 there. Okay, so go back, fix it. This is to the power 2. Power 2 there. What am I doing? This calculator. Let's see. Let me start again. It's okay. Bracket, which is 2 bracket to the power 3 minus 8 bracket 2 bracket squared. Then we have plus 2 plus 2, which is plus 4. We have plus 4. Then I get my remainder, which is equal to 4. And that's the remainder theorem. If we just substitute the x value into your polynomial, you get a remainder. You get a remainder if that is a remainder theorem. I hope it makes sense and you're trying this hard. Good. Fantastic. Let's look at the next question. Now, the next question. Now, when f at x, there's the polynomial, but we don't have, can you see there, x cubed, but with the p there, plus x plus 1. If this polynomial is divided by x minus 3, the remainder is 4. Determine the value of p. What do we have here? We have a polynomial, but with p value there, which we have to find. But when this polynomial is divided by that value, it leaves a remainder of 4. Determine the value of p. I think we just have to formulate an equation. What does it mean? Let's see what it means. It means that if I take that, which is x minus 3, 0, same principle, x is equals to 3, it implies that if I take f at 3, remember, you get the remainder. If you substitute 3, you get the remainder. But now, what is this remainder? It's given, which is 4. So this means that f of 3 is equal to 4. Then now, I can able to solve for p there. So let's see, this part. I can do this part, which where I see x, I substitute 3, so which is 3 to the power 3 minus p, which is 3 squared plus 3 plus 1. This leaves a remainder of 4. I'm happy now. I can see I have one variable. Then this is an equation. I can manage to solve this. Okay, great. The 3 to the power 3, which is 27. This is 9. 9 times minus p, which is 9p. And these two terms, I get 4. I get 4 for the two terms, which is, let me erase this, let me write properly, which I get 4 equal to 4. Then what happened, if you can see that this 4 and this 4 cancels, I have a simple linear equation. Then I can do what? This is minus p equal to minus 27. Then what do we have? You can divide by minus p both sides. Minus p, minus 9 both sides. Therefore, p equals to 3. Good. Good. This is beautiful mathematics. I hope you understand this problem, guys. Okay.
Okay, guys, I hope you are enjoying this revision session. If you need help, remember to post on the page or send an email to helpdesk@learnextra.co.za. Now it's time to take a quick break, but don't go away. We'll be right back. Welcome back, guys. We have some great news to pass on to you. We will be bringing you winter school from the 30th of June till the 20th of July, starting at 10 a.m. every weekday. To get the full schedule, visit our website, learn.mindset.co.za, and look for the winter school link. Join us. It's going to be a lot of fun. But now it's time to get back to the lesson.
So the first question that we've got here is the question about going back to limits and question about evaluating limits. And it's really quite straightforward up to a point, because I want to show you something. It's quite tricky. You've got to keep your wits about you. This first one, it says evaluate this limit as x tends to 0, 5x minus 0. Well, in this case, all we're going to do is we're going to say, if I take 5 and I let x equal 0, then it's 5 times 0 minus 5 equals minus 5. So I would evaluate that by just substituting the 0 in and recognizing that it gets to minus 5. If I wanted to test it, I could take values a little bit before 0. So I could take like 5, 0, comma 1 or 0, comma 0, 1 minus 5 and see what I'm going to get to. And it's quite a nice exercise in calculation. You'll get an answer here of minus 4, comma 9, 9, dot, 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 dot. Okay? Something like that. You could also take a number that's slightly bigger than a 0. So you could, or less than 0 at least. So you could take one that's slightly less than 0. You could take 0, comma 0, 0, 0, 1 minus 5, and then you're going to see that the answer here is going to be 5, comma 0, 0, 0, 1. It's slightly above. And they follow a trend. It makes sense that as we get closer and closer to 0, it converges to a number which is minus 5. Okay. That's the idea of a limit. And we should test it above and below. They don't always do that. Sometimes just straightforward to see what it's looking like, except when you get something tricky like this. Now, as soon as you get, if we took away the limit, that's part of that. We didn't look at that. What would we know about this? Well, we would know immediately that x cannot be equal to 1. Can't be equal to 1. Why? Because dividing by 0 gives you an undefined answer. But what have they asked us? They've said evaluate what happens as x gets to minus 1. Now, strictly there is no answer to that. But in the limit, as it gets there, is there a possibility of us getting an answer of what it should be? What's the most likely value? Well, one of the things that we can do, fortunately, is we can do a little bit of algebra here. So we can say, in the limit, as x tends to 1, let's factorize x squared minus 1. I'm going to factorize it as x plus 1, x minus 1, and I'm going to put x minus 1 as the denominator. And look at that. That's quite cool. Because what do I recognize? That those two can cancel out. And now what I'm left with is the following. I've got the limit as x tends to 1 of x plus 1. So as x tends to 1, what's the limit going to be? Put 1 in place of x, and the limit tends to 2. Now, guys, this doesn't mean that 2 is the answer to this, to the value of the function at that point, because we can't divide by 0. But in the limit as x, the answer is 2. Because even with calculus, the derivative wouldn't exist because that h can't be 0 really. But in the limit, it tends to 2. The number that it's converging towards is 2. We check that out. Right. Now, the next question. Guys, this is a really important thing. And I've only got about 6 minutes to do it. So I want you to pay careful attention. You will get a question like this either in the June exam or the prelim exam and the final exam, or in all of them. there are a limited number of functions they can ask you to derive from first principles. But your setting out is crucial. And I'm going to go through your setting out, and I've chosen probably one of the most difficult ones to do. So it tells us to find the derivative of f of x, which is equal to 2 over x from first principles. So the first thing I'm going to write down is what is f of x. And f of x is equal to 2 over x. What is f of x plus h? And I'm going to write this as 2 over x plus h. So now, what's my derivative? I want to find the derivative. Remember, the formula is on the data sheet. F dash x is equal to the limit as h tends to 0 of f dashed x, sorry, f, I mustn't put the dash in. Replace that for the minute. Just erase that part. There we go. F of x plus h minus f of x. And now that's the change in y. We're wanting the change in x. The change in x value is just going to be h. Okay? That's what we're looking at. And so now it becomes a little bit of an algebra problem, because all we've got to do is we've got to take this input and that input and put them into the equation. And we do that without forgetting in each line to write down the limit as h tends to 0. And I'm going to put that in now. So I'm going to say x plus h over 2 minus x, 2 over x, and at the bottom line h. Now, this is where you have to stay alert. In some cases, you're going to have to expand. And because there's a negative sign here, you need to make sure that everything on the right of that negative sign, the negative sign is applied to it. In this case, you've got a fraction. So how do we deal with fractions? And I'm going to take it very simply, and because I'm not as confident in some of this as some other people are, I'm going to take the common denominator. And I'm going to say to myself, x plus h times x is my common denominator. So how many times does this go? I'm going to say x plus h into the common denominator goes x times, 2 times x, and I will have a 2x on that side. And then on this side, I'm going to say minus 2. And how many times is x? It goes minus 2x plus h times. Now, please take note of that. I've got this all over h. So it's now getting a little bit messy because I've got denominator and numerator, and I haven't expanded. I'm going to expand the numerator, and we're going to see what it looks like. H tends to 0. Don't forget that. We're still letting that go. We've got h on the on the very bottom denominator. Then we're going to say 2x. Now, minus 2x minus 2h over x plus h in brackets x. It's still looking a bit messy. What am I going to do? What I've got to remember is the rule of tip and times. So what I really want to get to the point is cancelling out the h in the denominator. And that's exactly what I'm going to try and do right now. So recognize that this part needs to be divided into this whole thing. If I've got a fraction, think about that as h over 1. I'm going to tip and times, and I'm going to therefore write this as the limit as h tends to 0. And on the top line, I've got 2x minus 2x. Notice that 2x minus 2x, that can cancel. There's something that I can cancel out. I'm going to cancel it out. So be very careful. Look for those things that you can cancel. That can cancel with that. What am I left on the top line then? On this very top line, minus 2h. And can you see what's happening? I invert minus 2h, x plus h times x, and times this by 1 over h. Now, look here. This is so exciting. I'm almost going to cry. Look what happens. Those cancel. And I can now write the next one. Limit as h tends to 0, and I've got minus 2 on the top line. I've got to expand on the denominator now. X times x is going to give me x squared plus x times h. Now, guys, please notice, it doesn't matter that I've got an h on it, in the denominator. This h doesn't matter because it's with an x and there's another bit there that's going to keep me safe. So I'm no longer dividing by 0. I can simply say, right, I can evaluate it. I can now drop the limit. I can say let h equal 0. If h equals 0, what am I left with? Minus 2 over x squared. And that's the derivative function.
We have been given an equation which is in the form of f of x equals negative 2x cubed plus 5x squared plus 4x minus 3. And we are required to draw a sketch of f of x. And they've just specified that we need to clearly indicate x-intercepts, y-intercepts, turning points, etc. Okay, so let's break this down into steps. The first thing that we need to establish is what kind of shape is this cubic function going to have? Is it positive or is it negative? Now, by looking at my equation, this negative 2 over here is the value of your a. And remember, we spoke about it previously. If your a is less than 0, it is negative. So I know that my shape of my cubic function is going to start by decreasing. It will increase between the two stationary points, and it will continue decreasing infinitely at the end. Okay, so that's step number 1. Step number 2, let's quickly establish our y-intercept. Y-intercept is always quite nice and easy because all we have to do is let x equal 0. And if I let x equal 0, I would have negative 2 times by 0 cubed. I would have 5 times by 0 squared. 4 times by 0 minus 3, which means that everything cancels out, and we are left with y equaling negative 3. So that's our y-intercept, done. Now we need to work out our x-intercepts. Okay, the x-intercept is generally the one that requires a little bit more working out. Okay, so let's work out our x-intercept. And this is where we say let y equal 0. Okay, so I've got 0 is equal to, let's just get back to our equation. It was negative 2x cubed plus 5x squared plus 4x minus 3. Okay. We are going to have to use a method that we learned in previous lessons called your factor theorem here, okay, because we need to factorize this cubic expression. So, first things first, because it is equal to 0, this negative, we can take out negative, we can basically divide everything through by negative 1. And as a result, 0 divided by negative 1 is still just 0. I'm going to have positive 2x cubed, negative 5x squared, minus 4x plus 3. So everything has been divided through by negative 1. Now, using the factor theorem, we need to establish a factor. We need to find, and it does mean by means of a trial and error, find a factor that will give us an answer of 0 when I substitute values into x, okay? Now, when we say it's trial and error, it's guided trial and error, because what we need to do is look at the last term. I need to look at this 3 over here. Whatever I substitute into x has got to be a factor of that 3, which limits me down quite severely down to really just 1 and 3, or if those don't work, we have to try negative 1 and negative 3. All right. So let's start and let's do a bit and see what we can do. I'm going to substitute x equals negative 3. Okay? So I've chosen that as a value. Let's see if we'll end up getting 0. So what I'm working with is f of negative 3. So we have got negative 2 times by negative 3 cubed plus 5 times by negative 3 squared plus 4 times by negative 3 minus 3. And what we need to do is we need to put that in our calculator, and let's see if that gives us 0 when we work it all out. So I've got negative 2, negative 3 cubed, plus 5 times by negative 3 squared, plus 4 times by negative 3 minus 3. And okay, no, so that didn't work. Let's try positive 3. Let's see if positive 3 works. So negative 2 times by positive 3 cubed, plus 5 times by positive 3 squared, plus 4 times by 3, am I right? And then minus 3. Yes, okay, it gave us 0. So the negative 3 didn't work, so I tried positive 3. That got me what I was looking for. So what I know, therefore, is that x, if positive 3 was the number I substituted into x, if I put it back into the bracket, x minus 3 is a factor. Okay? Now that I've established that x minus 3 is a factor, we need to work out how many times does x minus 3 go into our cubic equation. Now, there were methods that we learned how to do this, one of which is synthetic division, okay? This is just one of the methods, grade 12. You may have learned a different method, and really, whichever method works that you understand and that works for you, we're happy for you to use. I'm going to use the method of synthetic division, and that looks something like this. We take a divide and we take all the coefficients of your term. So I take negative 2 plus 5 plus 4 minus 3. So just to show you where they came from, I'm taking just the coefficients of each term. All right? And x minus 3 was your factor, so we put positive 3 outside that bracket over there. Okay, the method is that we bring negative 2 down, and we multiply. 3 times by negative 2 is negative 6. Positive 5 minus 6 is minus 1. And I multiply again. 3 times by negative 1 is negative 3. 4 minus 3 is 1. And multiply again. 3 times 1 is 3. And what you always want here is you want an answer of 0. If you get 0, you know that you've done it correctly. Okay. And filling in our descending powers of x, we've got negative 2x squared minus 1x plus 1. Bear in mind that we did have this equal to 0. So because it was equal to 0, I can get rid of that negative. So it's plus x minus 1. So that's how many times x minus 3 factorized into the cubic equation. And I need to factorize it one more time. So this trinomial we're going to factorize. So we're going to have 2x and x. Factors of 1 will be 1 and 1. And we're looking for a negative, so I'm going to have minus 2x and plus 1 will be the factorized answer over there. This all being equal to 0, because don't forget that was what we're trying to do to work out the x-intercepts. So after all of that working out, the 3 x-intercepts are negative 1/2, 1, and 3. Okay, so I've got my shape, I've got my y-intercept, I've got my 3 x-intercepts. What I now need to establish are my turning points or my stationary points, okay? And in order to do that, we let our derivative equal 0, all right? The formula was, sorry, let's just go back to it. It was negative 2x cubed plus 5x squared. So let's just write that down. Negative 2x cubed minus 5x squared. And let's just get the other part of it. Plus 5x squared plus 4x minus 3. Plus, so that was plus 4x minus 3. Okay? Now what we know is stationary points require us to find the derivative. So therefore our derivative is going to be negative 6x squared plus 10x plus 4. And the derivative has to be made equal to 0. All right? So this leaves us with a trinomial to work out, or a quadratic equation. Let's divide everything through by negative 2. That's going to leave us with 3x minus 5x minus 2 equals 0. And because it's equal to 0, I can divide by negative 2, and that will cancel. All right. Okay, and it's a trinomial, so let's factorize. I've got 3x, and I have got x. factors of 2 is 2 and 1. We're going to have to put our 2 and our 1 in those positions there because we want a negative 6 and a positive 1. Leaving me with two values for x of negative a third and positive 2. All right. So what have we found? We have found the x coordinate of your stationary points. But like any point, if it's got an x coordinate, it needs a y coordinate. So we are now going to have to substitute. We're going to have to work out f of a negative a third, and we're going to have to work out f of 2. Okay? And let's quickly see if we can do that. Right, so we have got, let's see if we can go back. Let's clear that. All right, so we have got negative 2. Now what I'm doing is I'm substituting this back into the original equation, always back into the original equation, and we are cubing that, plus 5 times by negative 1/3, negative a third squared, plus 4 times by a third, negative a third, sorry, that's, otherwise you're going to end up having problems there, negative a third, and then close that bracket, and finally minus 3. Right, so what is that giving us? Okay, that looks like a very difficult point to plot, but if I change it to a decimal, negative 3.7 looks a bit more realistic. So negative 3.7 is the point over there that we're going to have as a y coordinate, and if I substitute 2, I've got negative 2 times by 2 cubed, plus 5 times by 2 squared. No, that's, oh goodness. Let's try again. Negative 2 times by 2 cubed, plus 5 times by 2 squared, plus 4 times by 2 minus 3, and we're getting 9. Right, so they're my turning points. So I have negative a third and negative 3.7. I've got 2 and I have got 9. So let's sketch this graph over here. So we're going to give ourselves x and y axes. And let's see, we knew that we had, let's go back to the x and y intercepts. Let's go back up here for a second. Right, x-intercepts were at the y-intercept. Y-intercept was at negative 3. My x-intercepts were at, let's go down a little bit further. X-intercepts were at negative a half, 1, and 3. So negative a half, 1, and 3. All right, so we had negative a half, 1, and 3. Turning points. Turning point was at negative a third. Okay, negative a third and negative 3.7. Okay, I'm just estimating. I'm not having, it's not to scale. 2 and 9. So if that's 2 and 9, we've got our points up here. And just one final thing to remember was at minus 3. Yes, okay, so the y-intercept was at minus 3. All right, so it's a decreasing function, so it begins by decreasing. It passes through my first x-intercept. It gets to my turning point where it turns around. It comes up through your y-intercept, all the way up. Okay, that's missed that point slightly. Sorry, my sketch is not 100% accurate. And it turns around. Let's just fix this point over here to make it look a little bit nicer. Go back to here. Let's just sketch that a little bit better. So that will go through there, and this point over here was 1. It was 1. Okay. All right, so we therefore have our f of x function, and just label, give the coordinates of your turning points, and just make sure that everything is clearly labeled.
I think it's time for a break now. Don't go away. We'll be right back. Welcome back from the break. Let's not waste any time and get straight back to today's revision lesson. Over to you.
One side of a rectangle is given as the length of 500 plus x millimeters in length. The perimeter of the rectangle is 500 millimeters. So what we have to do is find x so that the area of the rectangle is at a maximum. Okay, wow, we've got a whole lot of stuff happening here. We're talking about a length, which is, okay, 500 plus x. Whoops, let's just go back there. Okay, we're talking about our length, which is 500 plus x. Okay, so let's fill that in on our diagram. So we know that we've got 500 plus x. And obviously, what we know about a rectangle is that the opposite lengths are equal to each other. So if that's 500 plus x, then what we should know is that this is also going to be 500 plus x millimeters. All right? They haven't said anything about the width, so at this point we can't really do anything with that. They have, however, spoken about the perimeter. All right? So let's just remember the perimeter represents all the lengths, the sum of all the sides of your rectangle. All right? So what we know is that length plus breadth, all together, they're telling us, is equal to 500 millimeters. Okay? So do you agree, grade 12s, that's probably a good place to start. Okay? Let's give ourselves an equation for the perimeter. We know that twice of our length plus our breadth is equal to the perimeter, and the perimeter they've told me is 500. So 500 is equal to twice of the length. Now the length we know is 500 plus x, plus the breadth. Well, the breadth at this point I don't know what it is, so I'm going to have to leave it like that. Okay? So let's solve for the breadth. I've got 500, which is equal to 500 times 2 is 1,000, plus 2x, plus 2 breadth. Okay? And that's going to be, let's see, we've got 2, let's move it over to the side. So 500 minus 1,000 minus 2x is equal to 2 breadth. Okay? And let's see, so that's going to give me negative 1,000 minus 2x equals 2 breadth. And I need to divide by 2 so to get breadth on its own. So therefore, negative 500 minus, no, that hasn't actually worked out, minus 2x equals breadth. Let's just double check that. I just want to make sure, guys. So 500 minus twice of the breadth minus twice of, okay, sorry, let's just fix that up there. Okay, so 500 minus 1,000 plus 2x. Okay, so yes, that is giving us negative 500 minus 2x. Okay. All right, so that's then representing your breadth. All right, so that's what we've got for now. Now the question wants to know, we have to solve for x in order to maximize the area. That's what the final thing is asking us, to maximize the area of your shape. Okay? So now we have to think, okay, the area of a rectangle, just plain old area, is going to be just length times breadth. Okay? So therefore, we're going to have to make a formula which represents the area of my rectangle, which is just our length times by the breadth. Okay? And when we have that formula, we then, okay, so let's just times that out. Let's see, that's going to be 10,000. I've got minus 1,000x. I've got plus 1,000x. And I've got plus 4x squared. Okay, so I've just FOILed that out. And, okay, so let's just simplify that. So we've got 10,000 plus 4x squared, all right? And that represents your area, okay? So now that we've got the formula that represents the area, the next thing we need to now do is work out what's going to be the value for x that will maximize that area. So the next step in this process is I'm then going to have to take the derivative on, but let's get the correct notation here. The derivative of your area. So we're going to say the derivative of your area in terms of x is equal to, I don't know why this hasn't worked out. 8x, and I'm going to have to come back and check this somewhere I've made, I don't know, there's a silly mistake here somewhere. All right, so I'll go back and check that in the break and just double see where I maybe worked that out. But anyway, the concept that I want you to understand for now is that you've got your derivative equals 0 to work out your area. I'll come back to that one, guys, and I'll see what we did funny there. Let's have a look at the next one and see what we can do here. Right, bricks are to be painted with a special paint for use underwater. The bricks are rectangular in shape, and the length of each brick is 3 times its breadth. The volume of cement in each brick is 972 centimeters cubed. If the height of a brick, if h is the height of your breadth, and x is the height, and sorry, I'm not getting confused. H is your height, x is your breadth. The first thing they're wanting me to do is express h in terms of x, okay? This is an important concept to watch out for. If you've got a situation like this, where you've got two different variables, grade 12, you've got your h and you've got your x, okay? The first thing you actually are going to have to do is try and write the one variable in terms of the other, all right? So that's what we're going to have to do. And the way we're going to go about doing it is we're going to go back to the information that they've given us over here. First of all, they said that the length was 3 times the breadth. So therefore, this is going to have to be 3x as a length, okay? And they've told me that the volume is 972 centimeters cubed, okay? So that's going to imply, guys, that we're going to have to go to our volume formula. The volume of a rectangular prism is the length times by the breadth times by the height. The length is 3x. The breadth is just x. The height is h, okay? The volume, we have been told, is 972 centimeters cubed, all right? So we're going to use that as a starting point, and we're going to say, okay, 972 is then equal to 3x squared times by h being your height. And the whole purpose of this is that we're trying to solve h in terms of x. So what I'm going to then do is take this 3x squared, and I'm going to divide it on the left-hand side, so 3x squared. And that gives me a formula which says, let's write it over here, that h is equal to 972 over 3x squared. 972 divided by 3, let's just see if that's 972 divided by 3, 324, okay, fine. So we can simplify that to say 324 over x squared. That's the formula for h in terms of x. So that's always going to be your starting point. You look carefully at what you've been given in your information, because something there is going to tell you how to write the one variable in terms of the other, okay? Now that we've got that, it says express the total surface area of the brick in terms of x, okay? So this is where I say you need to know those formulas for surface area and volume, because this is an instance where we would have to apply it, all right? Surface area, we've spoken about, is the area of the base. Now, the area of a rectangular prism is length times breadth times by 2, plus the perimeter of the base. So that's twice the length plus the breadth times by the height of your shape, okay? So if I were to apply this to my shape, the length is 3x, the breadth is x, and we're timesing that by 2, plus 2 times my length, which is 3x, plus my breadth, which is just x, and we're timesing that by the height, and don't forget that the height has now been written in terms of x, so we're going to refer to it as 324 over x squared. Okay, and if we tidy that up, let's see what we've got. We're going to have 6x squared. 6x squared. All right. Plus, okay, so that's going to be 4x times 2 is going to give us 8x multiplied by 324 over x squared. Okay. Obviously, this is being multiplied, so we can simplify with my x's. And 324 times 8 times by 8 gives us 2,592, 2592. 2592 over x and 6x squared. Right, so this formula represents the surface area of your prism. All right, so I hope you guys could see how I applied that formula that I was speaking about earlier. Now that we've done that, the question finally says, calculate the dimensions of the brick, the dimensions being the length, the breadth, and the height of your brick, that will minimize the amount of paint required. Okay, so therefore what we're going to do is we're going to take the derivative of your surface area formula in terms of x, that's the variable, and we're going to let it equal 0. Okay? Before we can find the derivative, remember that if it's over x, we cannot apply our rules of differentiation. So before we do anything, I am going to have to bring 2592. I'm going to have to bring that up to the top to make it x to the negative 1. And then we can find our derivative of our surface area. dx. Okay. So therefore, 6 times 2 is 12x. That's going to become negative 2592x. And that's going to become to the negative 2. All right? And what we're now going to do is let it equal 0. So I've got 12x minus 2592 over x squared. And in order to simplify this, let's balance this. Let's put that over 1, and let's find a lowest common denominator. So 0 is equal to my LCD of x squared. Therefore, if I multiply by x squared, we're going to land up with 12x cubed. And minus 2592. Okay? And once we've done that, we can drop our denominator, leaving us with just. Now let's just see here, 2592. If we divide that by 12, 216. Okay, so what I'm basically doing here, grade 12s, is I'm taking out 12 as a common factor, all right? And by taking out 12 as a common factor, we're left with just x cubed minus, 216 was our number. And that's what we've got over there. Right, do you recognize that that is actually a difference of 2 cubes? Okay, the factorizing that we're going to have to now apply is difference of 2 cubes. So we've got x minus the cube root of 216. So if I take the cube root of 216, we've got 6, okay? And the method is we square the first term, we square the last term, we multiply these two terms together, and we always change the sign, okay? If you recall your method of difference of 2 cubes, grade 12s, if you try and factorize and solve for your second bracket, you will always land up with no solution, okay? So in fact, the only solution I am getting here is that x is equal to 6, okay? So the question wanted to know, what were the dimensions of my brick? So all the way back to the beginning. My breadth would then have to be 6 millimeters. My length would have to be 3 times 6, which is 18. And my height would have to be 324 divided by 6 squared, which is obviously 36. And that would give you your height. Okay, there we go. So I hope that you guys understood that. And let's have a look at another example.
Right, Tamilin. Before you move to another question, there's actually a mistake that the mindsetters have
Did
spotted
they pick it up?
on the first question,
Okay, let's go back. Let's see. What did I do?
where you were saying 500
Yes.
minus 1,000.
Yes.
You said it's equal to 1,000.
I said sorry.
There, just there on 500.
Yes.
Down, down, down.
Uh-huh.
Yes, there, there.
Okay. 500. Sorry, I think the nerves got the better of me there. So it was minus 500. Minus 2x was 2b, so it was 250. Okay, so there we go. So that was the mistake. Sorry,
Cool.
guys.
Thanks.
That was a silly mistake, and I do apologize for that.
Thank you.
Okay, but I'm glad you picked it up. Sometimes it's easier to see these things on the other side. Okay, all right. Let's have a look at one where we talk about a cylinder over here. Okay. All right. So now we have got the total exterior surface area of an empty cylinder, which is closed on one side. Okay, that's an important little detail that I want you to take note of. Only closed on one side is 462 centimeters squared. Okay, so what have they given us? They've told us that the surface area, that's the area of all the outside faces of your shape, comes to a total of 462. But they have specified something. They've said that it's only closed on one end. Okay? So imagine a tin can that you've taken the lid off and thrown that away. The bottom is still a metal base, but there's nothing at the top. Okay? So if I was working out surface area, if that was the case, do you agree, there would be nothing on the top to actually work out. So in this case, we have to adjust our formula just a little bit. All right? We have to say this. Surface area would then be equal to the area of the base, all right, which in this case is obviously pi r squared because it's a circle, all right? So area of your base, but I'm not going to times it by 2, all right? And I hope you guys understand why, because the top is not there. It's an open top, okay? So it's the area of the base, just as it is, plus the perimeter of the base times by the height. perimeter of base times by the height. Okay, so just watch out for little details like that, because obviously that makes a difference in terms of what formula you're going to actually need to use. Right, so if they've told me that information, then quite obviously I'm going to have to use it, okay? Once again, do we notice that I've got two different variables? I'm talking about a variable of h representing your height and r representing your radius, okay? Find the height of the cylinder in terms of pi and the radius. So the first thing we have to get rid of here, guys, is that we have to write h in terms of pi and r. Why? Because obviously then we only have one variable to solve for, okay? So we're going to use our surface area information in order to do that. The surface area was 462, so 462 centimeters squared was equal to the area of the base. Now the area of my base is just pi times by the radius squared, and I'm not timesing it by 2, plus the perimeter of the base, which is 2 pi r, times by the height, which for now we know is just h, okay? And with that, we need to now get h on its own. All right, so first things first, let's take 462. I hope you guys don't mind, but I'm going to write up here with a bit more space. 462, I'm going to subtract, so I'm going to minus pi r squared, and that's going to leave me with 2 pi r h on the other side. And to get h completely on its own, I'm going to have to divide by 2 pi r. Okay, so 462 over, minus pi r squared all over 2 pi r. We could simplify this a little bit. Let's split it. Let's write it as 462 over 2 pi r minus pi r squared over 2 pi r. And that's now equal to h. 462 divided by 2 is going to be 231 over pi r minus, okay, the pi's can cancel. This r will cancel with one of our r's in the numerator. So therefore, we're left with r over 2, and that's your height. Okay, so what I've done is I've manipulated it. I've changed it so that I'm no longer going to refer to it as h. I'm going to refer to it as 231 over pi r minus r over 2. And everything there is now in terms of pi and r. Okay. Now that we've done that, the question actually wants to know, find the value of your r for which the volume will have a maximum. Okay. So now we've got to turn to the volume formula. Volume being area of base times by the height. Okay. The area of my base was pi r squared. That actually didn't change. But the height of my formula is completely different now. We're using this formula here. We're using our 231 over pi r minus r over 2. Okay, and that's representing your volume. Let's simplify this. If I were to distribute this into both first term and second term, let's see. The pi's will cross-cancel, the r's will cross-cancel. So I'm going to be left with 231 r from my first term. From my second term, I'm going to have, let's see, it'll be pi r cubed over 2. Okay? So everyone can see what I've done there. That represents your volume. What have I done? What do I need to do from here now to work out the maximum volume? We're going to find the derivative of your formula, and we're going to let it equal 0. Our derivative, if we just scroll up slightly, remember our volume formula was 231 times by r minus pi r cubed over 2. Okay, so we had to find the derivative of that. The derivative being 231 minus 3 over 2 pi r squared equals 0. And then we need to solve the equation. All right, so we needed to bring our 3 pi r squared over our equal sign, which obviously made it positive. Instead of, let's just use a different color, and for the benefit of our mindsetters, I'm not going to use green. Okay, we were told not to use green. Okay, 3 over 2, how are we going to get rid of that? We tip and times it. So I multiply by 2 over 3 on that side. By doing it, I got 154 equals pi r squared I then divided by pi to get 49.02. And finally, you square root 49.02. Your calculator gives you an answer of 7.001. So obviously, if I round that off to the nearest 1 or 2 decimal places, we actually land up with just 7. So there we go. So the question wanted to know what was your R going to have to be in order to maximize the volume of your cylinder. And 7, I think the units was centimeters. Was it centimeters? Okay, they didn't actually state. So in that case, all I'm going to write is 7 units as your radius.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Remember to visit our website, learn.mindset.co.za, to get the notes and to watch the videos from the term. Goodbye.